Hello and welcome back, Math 130 students. We are going to pick up on page 8. This is section 1.2, part B. So this is the second section of 1.2, and we're picking up on page 8. So we are going to start with this example here with the stamps. So it says, Yumi spent $34.15 buying stamps. The number 56-cent stamps she bought was 10 less than 4 times the number of 41-cent stamps. How many of each stamps did she buy? So for this problem, the easiest thing to kind of fill out here would be my value, because it already tells me in my description how much each stamp is worth. The 56-cent stamp is worth 0.56. The 41-cent stamp is $0.41. Now for the total amount, that means I'm counting, right? So how many of each did she have? Well, it says that the 56-cent stamps she bought was 10 less than 4 times the number of 41-cent stamps. So here, what is that 10 less than 4? This tells us subtraction. Not only does it tell us subtraction, but it also tells us to reverse the order. So notice how it has 10 less than 4. So that means 4, well, it's 4 times the number of blah, 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 blah. So 4 times blah, 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 and I have my subtraction, and 10 is going to come last. So now you need to figure out that blah, right? What am I multiplying 4 by? Well, I'm multiplying 4 by the number of 41-cent stamps. So do I know how many 41-cent stamps I have? I do not. So this is my unknown. So that is going to be my point of reference. So that's going to be my x. So then the amount of 56 cent stamps, which is here, is going to be given to me as 4. And remember that blah is now going to be the x. So it's 4 times x minus 10. So now for my combination, what I do algebraically is I multiply the first two rows together. So I have a 0.56 times a 4x minus 10. If I multiply the last two rows together, I get a 0.41 times this x. So what's really nice about this is that your combination or your equation is going to come from that last row. So the combo added together is equal to your total amount. And here, your total amount is represented by that $34.15. So now your equation is 0.56 4x minus 10 plus 0.41x is equal to 34.15. So now you want to distribute that 0.56 into everything. So if I have 0.56 times that 4x, that is going to give me a 2.24x. And if I do 0.56 times a negative 10, that's going to give me a negative 5.6. And I still have a 0.41x, and I have that equal to 34.15. So now when I combine like terms, so I'm going to add the x's together. So that 2.24 plus that 0.41 is going to give me a 2.65x. And it's going to be minus 5.6 is equal to that 34.15. So then from here, I'm going to add that 5.6 to both sides. So I have 2.65x. And now I add those two numbers together. So 34.15 plus 5.6, that's going to give me 39.75. So then from there, I divide out by 2.65, divide out by 2.65. And when I plug that into my calculator, I'm going to get that x is equal to 15. And remember, your original equation did not say find x. your original equation or your original question tells you or asks you how many of each stamp did she buy. So you have to answer this question. So to answer that question, you're going to say the amount of 56-cent stamps, and you're going to give the amount of the 41-cent stamps. So I need to put in a value for both of these. So I know at the very least that the amount of the 41-cent stamps, remember, was X. So this was X. And what was X equal to? X was equal to 15. And don't forget the 56-cent stamps. Well, this one was equal to a 4x minus 10. So I have 4, and what I'm going to input is that 15. So 4 times 15 minus 10, that's going to give me a total of 50. So 50 total stamps I'm going to have. Okay. Hopefully that makes sense. Okay, so our next word problem. We're going to be talking about tickets. One afternoon, the water park sold 525 tickets for a total of $13,545. Child tickets cost $19 each, and adult tickets cost $40 each. How many of each kind of ticket were sold? So here, again, what I would try to do is go with the value first. So I know that each child ticket is $19, so that's going to be my value. And I also see that each adult ticket is $40. So that's going to be my value here. I also want to figure out how much amount I have of each ticket. So I know the total is 525. Okay. And I do not know how many child tickets and how many adult tickets I have. So let's say for the adult tickets, I don't know what that is. So I'm going to call that C. Well, I know that the amount of C plus the amount of the adult tickets is going to equal 525. So the way you can think about it is going to be, oops, let me get the eraser, there we go. So you can think of that first row as C plus your adult tickets is equal to 525. So if I were to subtract C from both sides, then my generic equation would be that the amount of the adult tickets, because I don't know how much that is, since I don't know the value of the child tickets, but I can write it algebraically as 525 minus C. And you can think of it as C minus C is equal to 0. So of course 525 is going to equal to 525. So now for my combination, I'm going to multiply my two rows together. So I'm going to have a 19C. I'm going to have a 40 times a 525 minus C. And in this box, right in here, I'm going to have my total value. So my total money, my total value is going to be that $13,545. So now my equation comes from that last row. So I'm going to have my 19C plus 40, 525 minus C is equal to that 13,545. So now when I distribute, I'm going to have 40 times 525. So that's going to give me 21,000 minus 40C is equal to 13,545. Now to combine my C's together, 19 minus 40 is going to give me a negative 21C. And I still have that 21,000 is equal to that 13,545. Now I'm going to subtract that 21,000 from both sides. So I can get negative 21c, and I have that 13,545 minus my 21,000 to give me a negative 7,455. So I'm going to divide by negative 21 to get the c isolated. So when I divide that by a negative 21, I'm going to get 355. So the amount of child tickets is going to be 355. So then the amount of adult tickets well, that can be easily figured out since here it's 525 minus c, so 525 minus that 355. And that gives me equal to 170. So I have 170 for the amount of the adult tickets. So the next type of word problems are going to be our motion word problems. So we usually have our distance, our rate, and our time. So for example, it says a motorist traveling 65 miles per hour for 3 hours will travel a distance of, and so we have to figure this out. So what we know is that distance is equal to rate times time. So we have our variables. Let's just figure out what number means what. So here, when I think of hours, well, is that a distance, a rate, or a time? Well, I'm thinking about hours. That is definitely a description of a time. And if I have, hey, what will it travel a distance of? Well, clearly, the distance is what you're trying to figure out. That's your goal. So your goal is to figure out the distance. So that leaves us with the only possibility that miles per hour, that's going to give you your rate. And you can think about that, right? A lot of people drive 65 miles per hour on the freeway. So that means that's their rate they're driving. So that's going to be your rate. Okay, so now if I have that generic formula of distance is equal to rate times time, then the distance is that thing that I don't know the value of. So let's just keep it as D. I have my rate as that 65. And it's being multiplied by my time, and the time here I said it's going to be 3. So now I know that my distance is going to be 65 times 3, which gives me 195. So it's 195 miles. And if you want to think about it, mph is your miles per hour. So you know that you're thinking about your distance in miles. Okay, for this example, I don't necessarily like this one because distance, rate, and time should be in hours and not minutes. So I'm going to skip this one. And I'm going to go to this one because it has it in hours, okay? So I definitely like this example a little bit better. So what does it say? It says, Lily is moving from Portland to Seattle. It takes her 3 hours to go by train. Mason leaves the train station in Portland and drives to the train station in Seattle with all Lily's boxes in his car. It takes him 2.4 hours to get to Seattle, driving at 15 miles per hour faster than the speed of the train. Find Lily's speed of the train and Mason's speed. So this is a lot going on. So what exactly is happening? It's definitely a distance, rate, and time, but maybe sometimes a little picture, it never hurts to kind of draw one out. So let's think about this. So I'm thinking about Lily, and she's going from Portland to Seattle. So she's going from her home, where she is. Home base is here, and that home base here is Portland. And she is moving, and of course it's not going to be a straight path, but more or less you get the idea that she's driving somewhere, right? So that's my road. And where she is going to be Seattle. And that is going to be her destination. Her destination here is going to be the train station. So to get onto the train station, then we can assume that this is also the train station, but it's a train station in Portland, and she's going to the train station in Seattle. So Lily, she goes by train. So going on the train, she's going this way. So this is Lily, and she's going on the train. Versus Mason, who's not Lily, that's somebody else. We have Mason over here. I guess he's helping Lily out by putting all of the boxes in his car. He's going in his car, and he's also going from Portland to Seattle. And so here, Mason is traveling by car. It says his car. So he's definitely traveling with his car. So what this is asking you to do, finding Lily's speed and Mason's speed, well, if I'm thinking about speed, then I want the rate of the train and the rate of the car. So here, Lily is going to be represented by the train, and Mason is going to be represented by the car. Okay? And if you want to think about it this way, the distance here is going to be the same, right? If I go from the Portland to Seattle, and you start in the same place and you end in the same place, it's definitely going to be the exact same distance, okay? So I'm just going to call distance D. They're both going to be D, and they're both equal to each other, okay? So distances are the same, okay? Now, it specifically gives us some values that we can plug into this chart. So it says it takes her 3 hours to go by train. So if I'm thinking about the train, then I'm here in the first row, and I'm thinking about hours, and hours is a time. So I'm going to put 3 in there. Now, if I'm talking about Mason, then Mason's in his car, and it says that it takes him 2.4 hours in his car. And I'm going to change the color on there because I'm getting too color happy, since I am talking about him and him being Mason. So it takes him 2.4 hours to get to Seattle. Now, this is a really important sentence. It says, driving at 15 miles per hour faster than the speed of the train. So here the train, I don't know the speed. That's unknown. So let's call that X. So the train, I don't know how fast it's going. It's going X amount. But I know that him driving, so that's Mason in his car, is driving 15 miles per hour faster. So if I have faster, that's going to be addition. So I'm going to have 15 plus the speed of the train, and the train we said was X. So I can say that this is going to be 15 plus X, or I can write it as X plus 15. Doesn't matter. So now I'm talking about the train. So the train, I have distance is equal to X, or better yet, since it's distance is equal to rate times time, then the train, I have my distance is equal to 3 times X. And whenever we have multiplication, it doesn't matter in what order we multiply, it keeps it the same. Now for Mason, his distance is going to be that 2.4, so the rate times the time, so 2.4 times that 15 plus X. And since the distances are same, it's the same as saying that they are equals. So you're going to set both equations equal to each other. So you have 3x, they are the same, so it is equal to that 2.4 x plus 15. So I still have 3x, nothing's happened to it, and now I distribute 2.4x, and now I'm going to have my 2.4 times my 15, which is going to give me a 36. So I'm going to subtract 2.4x from both sides. So I have 3 minus my 2.4x, and that is going to give me a 0.6x is equal to 36. Now you can think of division, so divide by 0.6 on both sides. So you can have 36 divided by 0.6, and that gives you 60. So what did the x represent? Well, x represented the train, the rate of the train. So I'm going to say the rate of train, which is Lily. Hers is 60 miles per hour. And now I have to talk about the rate of Mason, the car, which is Mason. And remember, he goes 15 plus x. But I already have the value of x. That value of x was 60. So I have 60 plus 15, which is going to give me 75. So Mason was driving 75 miles per hour in his car from Portland to Seattle. Okay, let's go on to the next page. So again, we have hours, so I'm going to go ahead and stick with the hours. So now I'm talking about buses. It says 2 buses go from Sacramento to San Diego. The express bus makes the trip in 6.8 hours, and the local bus takes 10.2 hours for the trip. The speed of the express bus is 25 miles per hour faster than the speed of the local bus. Find the speed of both buses. Okay, so I know this is just like the last problem, because it says to find the speed of both buses. So speed, that's going to be represented by rate. So that's what I'm trying to figure out. I'm trying to figure out the rate of both the buses, okay? So let's look at some clues that it gives us. So it says that the express bus can make the trip in 6.8 hours. So that's the express, that's the time, so 6.8. Now the local bus, that's what I'm talking about, it has it in a certain amount of hours, and that's going to be my 10.2. Now it's going to be talking about that express bus. So I'm thinking about my rate. It is 25 miles per hour faster, so it's 25 plus the speed of the local bus. Well, I don't know the speed of the local bus, so let's call that x. So the local bus is going to be rate x, and the express bus is going to be x plus 25. And again, I'm going to have my distances going to be exactly the same. So I know that distance is equal to rate times time. So for the express bus, I have that distance is equal to 6.8 times x plus 25. From the local bus, I have that my distance is equal to a 10.2 times x. Since they are exactly the same distance, then I set each equation equal to each other. So 6.8 times that x plus 25 is equal to my 10.2x. So now I'm going to distribute 6.8x plus, and now I'm going to multiply 6.8 times 25, which is 170. And that's still equal to my number, which is a 10.2x. So then from here, I'm going to subtract 6.8x from both sides. So I'm left with 170, and that 10.2 minus that 6.8 is going to give me 3.4x. And that number, I'm going to divide both sides so I can get the x by itself. So now I have 170 divided by 3.4, which is 50. So remember, x represented the speed of the local bus. So rate of local bus was 50 miles per hour. Rate of express bus, and I need to figure that out. Well, to figure that out, I know it's going to be x plus 25, but I know that that x value is 50, so I'm going to have 50 plus 25. So 50 plus my 25 gives me 75. Okay. That's very fast for a bus, but maybe that's why that's the express bus. For this word problem, again, I don't really like it because it's in minutes and not in hours. And I am going to skip this one. I've contacted the publisher for a mistake here, so that's fine. Here, for this example, so I have my commercial jet and I have a private airplane. So it says a commercial jet and a private airplane fly from Denver to Phoenix. It takes the commercial jet 1.1 hours for the flight, and it takes the private airplane 1.8 hours. The speed of the commercial jet is 210 miles per hour faster than the speed of the private airplane. Find the speed of both airplanes. So let's think about this. Again, it's asking for the speed, so I'm going to be thinking about the rate here. So what information do they have? Well, it says that the commercial jet is 1.1 hours. So hours tells me its clue for my time. So I'm going to have 1.1 for my hours. And the private plane, I have hours, and that's 1.8 for my time. So now it's going to be talking about the speed. So the speed of the commercial, oops, let's color code correctly. So commercial, I said, was blue, is 210 miles per hour faster. So that's plus, and that number that they gave you was 210. So it's 210 faster than the speed of the private plane. So the private plane, the speed, I don't know what that is. So I'm going to call that x. So the private plane is going an x amount. So then the commercial jet must be going x plus 210. And again, we have the exact same distance. So I know that my commercial jet is going a distance of 1.1 times x plus 210. And I have that the private plane is going to go d is equal to 1.8 times x. It's exactly the same on both for distance, so I'm going to set them equal to each other. So 1.1 times x plus 210. It's the same distance as that 1.8x. So now when I distribute 1.1x plus, and if I have 1.1 times 210, that's going to give me 231. And that's still equal to my 1.8x. So then from here, I would subtract 1.1x from both sides. So I get 231 is going to equal to a 0.7x. So divide by 0.7, divide by 0.7. So I'm going to have 231 divided by 0.7, so that x is equal to 330. And what did the x represent? X represented the rate of the private plane. So I'm going to have rate of private plane is 330 miles per hour. And the rate of the commercial plane is, remember, and I'm going to go ahead and circle this. Remember, the rate of the commercial was going to be x plus 210. And that x value that we figured out was that 330. So 330 plus 210 is going to give me a total. So 330 plus 210 gives me 540. So now I know the rate of each, the private plane and the commercial plane. Okay, and it looks like that is the end of section 1.2. Again, if you guys have any questions, please feel free to email me. Thank you.